have here is a 100 kilowatt setup. The 100 kilowatt setup, how it works with these Reebok batteries, these E66 batteries, is that you have a PDU which controls the balancing, the discharge, the charge. From there, the PDU communicates to the Reebok's RCs, and the RCs obviously go to the inverter. The RC also allows you to access on Wi-Fi the whole system, so you're allowed to see what's going on in your actual battery setup. Also, what we have here is that we've installed a main switch which basically goes to the inverter itself. So that will isolate the feed from the batteries to the inverter. That's just for an emergency or if you need to isolate. So what else I can speak about the system is that it has an emergency, not an emergency, so an emergency stop, and then it has LED indication. So green is for when the system is active and everything's fine with the batteries, so that's a good status. This is for when the batteries go low, and then this is for if there's actually a fault in the system and it goes in protection mode, it switches off the system completely. The batteries will not be active and it will not feed to the inverter. So that's pretty much it. Speaking about safety, so if someone's inside the container, and this is obviously other than me, also JNTM or the Reebok, if it's an authorized person and we authorize them to come and work in the container, then if they're in here and there's an emergency and you need to switch off the system completely, then obviously you would have to hit the emergency stop on the battery set, so the 100 kilowatt battery set, and obviously the emergency stop on the inverter. So it's vice versa, both sides have the same looking switch, the emergency stop. So then, as well as when you want to go and isolate the system, if we need to work on it, or if you need to work on it, so authorized person, then you would start basically by isolating the PV side. So how we usually work systems is we start with the PV and we work down from there. So then we go to the inverter side and we isolate everything there, and then the last thing is we isolate the batteries. So what I'll demonstrate to you basically, without switching off the system obviously because it's currently running, and I'll obviously demonstrate to you is how you would switch off the PV first when you do maintenance or if there's an issue. So you would switch off all these bigger looking breakers, so these black breakers. You'll see they're Benny, they're 1200 volt and they're 63 amp. You switch those off. That would isolate all the strings coming from the roof, and then you would go to the actual inverter side. And then you would come to the AC transfer DB. This is just so that you can give yourself power if there's an emergency or if the inverter is not working correctly. So you open up the AC transfer DB. And you basically, this is a transfer switch itself, that's a mechanical transfer. At the moment it's on grid and inverter, you would go to grid only, and that will completely isolate the inverter from the actual AC feed. So now you would switch off the PV. The PV, remember, doesn't have a feed anymore, so it's technically more safer to actually switch off. Then you would switch off the DC from the battery. Then you would switch off the grid breaker and the load breaker. Then it's completely isolated. The inverter won't be working. Then you would go to the front main part of the inverter, basically where the screen is, emergency stop and the LED indication, and then you would switch switch to off, and then the system will completely go off. If you want to switch off the system completely without going through that whole process and there's an emergency, you obviously hit the emergency stop button. The same as the battery side. So then you would also, like I said, it's good when you come into the container, it's good to just check if the actual inverter is working. So that will just be indicated by this power LED. That will just say that the inverter is working, it's inverting, it's giving power. But if it's in fault, then you know that, okay, there's obviously an issue with the system, either the battery side or the inverter side. So it works the same as the batteries basically. And then, so that's how we've isolated the system, either with emergency stop or you transfer it over to ESKOM. And then, like I said, you contact us if there's an issue, or we can basically go through the steps with you. We authorize you to actually go into the container. but it's probably it's best to actually contact us so that we can, either if it's a battery issue, we can contact Revo, or if it's more an issue with an inverter and stuff like that, we can contact the relevant people, or we can sort it out ourselves. To mention is that you would basically switch off that, and then you go to the inverter, isolate that, and then you would have to, the last thing is isolate the battery. So when it comes to isolating the battery, we look at first putting off the PDU, which is this white box here. So you basically put off the power button, and then you would also put off this lever switch to off position. Then you would basically go, so what that would do is it would isolate these battery sets for the rest of the system. And then you would start going to the other parts of the system. So you'd be looking at these breakers. So you put off the AC breaker, then the DC breaker, and then the last thing, and then also, so you would also put off these RCs. So these RCs have little batteries inside, you just don't want them to go flat, otherwise you won't be able to get the system engaged again. So you put off this little rocker switch here on the side, put that off, and on the opposite side, if you come this way with me, then you would see on this RC you also put that off. So this little rocker switch. Okay, once you've done that, then you would basically, the last thing you would do is you would put off this main breaker that is the feed to the actual inverter. That's the DC feed to the inverter. When you put it on again, this would be the last switch that you put on. But you would start, basically again, you would put that on, put the lever switch onto the on position, then you would start with the AC, the DC, put these RCs on so that it can engage. You wait for the green light to engage. You'll see the system would flash green first and then it would engage to green. That means the system is active again. And then the last thing you do is put the DC breaker on. That's if the system is good, it's in a good status, and then you put the actual DC on that will feed to the inverter. Last thing is, if we deem it safe to do so, then if you want to switch the system on again, you'd basically go in reverse. So you would start with the batteries, the opposite way of how we switch them off, and then you would go to the inverter, opposite way of how we actually switch it off, and then you would do the PV. The last thing, when the system is running, you do the PV. And that's just so that everything can engage, to feed power, and then you